Good morning, one and all. Today I am discussing about Module 1, Lecture Series 10 in Introduction to Soil Exploration under Applied Geotechnical Engineering 18 CV62 for 6 semester students. Today's our discussions are procedure and problem on dewatering and drainage methods, estimation of groundwater table by Hasley's method, and problems related to area ratio. The estimation of groundwater by Hasley's method. So in order to explain this Hasley's method, Hasley has given some procedure. As per that procedure, we are conducting this test in the field. Suppose I want to find out a constant water table. First, we have to make a borehole up to critical depth, insert the casing. After inserting the casing, continue the borehole by using auger method or shell method or wash boring method or any method up to the required depth. As the boring has proceeded, there is a pressure difference take place inside the borehole and the surrounding the borehole. As a result of it, the flow of water take place into the borehole. So, a drawdown curve creates here. Once the water is collected and the level of water in the surrounding area is equal to level of water in the borehole, the level of water in the surrounding area is equal to level of water in the borehole, then the water level becomes constant. Once the water level becomes constant, use some pumping arrangement for evacuation of water from the borehole. It has to be done until the entire borehole will become empty. That means the pump out quantity should be greater than pump in quantity. Therefore, so the entire borehole will become empty. Next is we have to watch at regular intervals what is the level of water raised in the borehole. If it is sandy soil or gravelly soil, within 2 hours the water level will come back to its original position. If it is clayey soil, it takes days together to reach the water table to the original position, because the permeability of flow of water in a clayey soil is very less. Permeability means what, students? The easy with which water flows through the body of the soil sample is called as permeability. So, let us consider after removing entire water, at time interval T1, okay, the head of the water will be H0. At time interval T0, it is H0. At T1, the water level will rises to H1. At again some time interval T2, the water level will rises to H2. Similarly, at time interval T3, the water level will rises to small h3. So now the constant level of water will be H0. How to find that constant level of water H0? So for first trial or day 1 is H1. So the day H0 minus capital H1. Similarly, H2 rise in the second day is equal to H1 minus capital H1 minus capital H2. Third day rise is H3, which is equal to H2 minus H3. Once you find out the H1, small h2, small h3 at a time interval, let us say T1 minus T0, that should be equal to T2 minus T1, that should be equal to T3 minus T2, let us say it as a delta T. So, as per Haas-Lays, he has given three formulas to calculate H0, H2, H3. So, H0 is equal to H1 square divided by H1 minus H2. Capital H2 is equal to H2 square divided by H1 minus H2. Capital H3 is equal to H3 square divided by H2 minus H3. Once you calculated H0, H2, H3, there is no H2, capital H2 here, please keep it in mind. So he has given that equation, we have to use it because there is an empirical equation he has proposed. Let the corresponding depth of water table level below the ground surface, that is, this is ground surface, below the ground surface, be HW1 for first day, HW2 for second day, HW3 for third day. If it is a steady state condition, then small HW1 should be equal to small HW2, small HW2 should be equal to small HW3. Coming to the small HW1 calculation, small HW1 is equal to capital HW, that is the depth of water table location after complete evacuation of water, minus H0, where H0 is equal to small h1 square divided by h1 minus h2. Similarly, HW2 is equal to HW minus h1, small h1 plus small h2 minus of capital H2. Capital H2 is small h2 square divided by h1 minus h2. Similarly, HW3 is equal to capital HW minus H1 minus H2 minus H3 minus capital H3. Now, as according to him, the location of groundwater table HW, small HW is equal to small HW1 first day water table location plus HW2 small HW2 second day water table location plus third day water table location HW3 divided by 3, average of these three values. Now, with this explanation, let us solve a problem related to estimation of groundwater table according to Haas-Lays method. So the problem is estimate the groundwater table level given the following data: depth up to which water is bailed out is 18 meter. That means for entire water evacuated in the borehole is 18 meter. That means to say your HW value. Water rise in the first day. First day how much water it has rise means 0.95 meters. Second day rise in the water is 0.86 meter. Third day rise in the water is 0.78 meter. Because when the entire borehole is evacuated with water means the surrounding pressure will be very high. Therefore, the rate of flow will comparatively more in the first day compared to second day and compared to third day. So they said that use Haas-Lays method. So now the estimation of groundwater table by Haas-Lays method, the same sketch that we are written here. So we know that small h1 is equal to h0 minus capital H1, small h2 is equal to capital H1 minus capital H2, small h3 is equal to capital H2 minus capital H3. Let small t1 minus t0 should be equal to small t2 minus t1, that is equal to small t3 minus t2, that is equal to delta H. With this assumption, h0 is equal to h1 square divided by h1 minus h2, that is 0.95 square divided by 0.95 minus 0.86, that is 10.08 meter is your h0. Similarly, h2 is equal to h2 square divided by h1 minus h2, or h2 is equal to 0.86 square divided by 0.95 minus 0.86, that is 8.22 meter. h3 is equal to h3 square divided by h2 minus h3. h3 is 0.78 square divided by 0.86 minus 0.78, that is 7.6 meter. So HW1 is equal to capital HW minus H0, that is 7.8698 meter. Small hW2 is equal to capital HW minus of H1 plus H2 minus of capital H2, that is 7.97 meter. Small hW3 is equal to HW minus H1 plus H2 plus H3 minus H3, 7.81 meter. If it has achieved steady state condition, means these values should be one and the same. If it is not achieved steady state due to so many reasons, soil properties will differ and size of the particle may not be same. Therefore, the average location of groundwater table is HW. It is equal to HW1 plus HW2 plus HW3 divided by 3, that is 7.92 meter. Next, consider tutorial class related problems. Compute the area ratio of a thin wall tube sampler having an external diameter of 60 mm and a wall thickness of 22.25 mm. Do you recommend this the sample obtained from this sampler tube as a UDS sample? Why? So the cutting edge external diameter is 60 mm. Wall thickness is 2.25 mm here, 2.25 mm here. So the internal diameter is D1, which is 60 minus 2 times the wall thickness. If you reduce it, it is 55.5 mm. External diameter D2 is 60 mm. Area ratio is given by formula D2 square minus D1 square divided by D1 square into 100. If you substitute 60 square minus 55.5 square divided by 55.5 square into 100, it will be 16.87. As we are aware that if the area ratio is less than 10%, then only it is a UDS sample. If it is greater than 10%, it is a disturbed sample. So in the disturbed sample, if waxing is done, so for prevention of evaporation of water, then we can say that it is a representative sample. In the problem, those related statements are not given with respect to moisture storage technique or how they are adopted. Therefore, we are assuming it as a disturbed sample, and obviously it is greater than 10%. Therefore, it has to be a disturbed sample or representative sample. Let us consider worst case, it is a disturbed sample. This much information you have to write it in the examination. Coming to the next problem, if the sampling tube pushed into the medium stiff clay at a bottom of the hole, a distance of 550 millimeter, the length of the sample required is 720 millimeter. That means, so this is your sampling tube. Okay, that sampling tube. So has pushed into the soil. So 60 centimeter length, the sampling tube has pushed into the soil up to 550 millimeter, and the sample collected is up to 520 millimeter. So whether it is a undisturbed sample or a disturbed sample, you have to say. It can be said only through recovery ratio. What is meant by recovery ratio? Recovery ratio means the length of sample collected in the tube divided by total depth of penetration. Total depth of penetration is 550 millimeter. Length of sample collected is 520 millimeter. Therefore, recovery ratio is 520 divided by 550 into 100 is 94.54%. In case of recovery ratio, if anything which is greater than 96% to 98%, we are calling it as an UDS sample. Present case is 94.954%. Therefore, it is less than 96%. Therefore, the sample is not a UDS sample, it is a disturbed sample. Coming to the next problem, the following size of sampling tubes are available in market. Outer diameter in mm is 75 mm, outer diameter in mm is 75 mm, inner outer diameter means this one is 75 mm, inner diameter is 72 mm, length of outer diameter is 75 mm, inner diameter is 72 mm, length is 600 mm. That is first sampler tube. Second sampler tube is outer diameter is for example, if I take this as a sampler tube, so this as a sampler tube, the outer diameter is 110 mm, inner diameter, if you reduce the thickness, inner diameter is 107 mm, and the length of that sampler tube is 600 mm. Third sample, outer diameter is 50 mm, inner diameter is 35 mm, length is 600 mm. So out of these, which one would you select for obtaining UDS sample for a borehole is the question. So we are all aware that area ratio is given by d2 square minus d1 square divided by d1 square into 100. The outer diameter we have to call it as d2, inner diameter we have to call it as d1. There are three tubes are given, three area ratios you will get it. For the first area ratio it is 8.5%, second area ratio it is 5.6%, third area ratio for 50 mm outer diameter and 35 mm inner diameter it is 104%. So if you carefully examine these results, any sample whose area ratio less than 10, we are calling it as undisturbed sample if we collected through that sampler tube. Here the question is, which one is more undisturbed sample? Area ratio 1 is 8.5%, less than 10%. Area 2 is 5.6%, which is also less than 10%. Among these two, which one is a more undisturbed sample? So if you see the results, the area ratio 2, which is having a area ratio of 5.6%, which is much more lower than the 8.5%. Therefore we can recommend, because they ask us to recommend it, so we can recommend area ratio 2 or the sample which is having outer diameter 110 mm, internal diameter 107 mm. We are recommending it as the best UDS sample tube. Coming to the multiple choice question related to today's discussion, estimate the depth of groundwater table by Hasley's method. So Hasley's method is used to estimate the groundwater table. Option A is true, option B is false, option A it is true. Question number 2, estimation of depth of groundwater table is not done by Hasley's method. Option A is true, option B is false. As per the textbook informations, as per the classroom discussion, Hasley's method is used for determining the groundwater table. Therefore, this statement is wrong and answer is B, false statement. Hasley's method for H0 is given by H1 square divided by H1 minus H2. Formula is correct. Option A, true. Hasley's method for H2 is determined by H2 square divided by H1 minus H2. The statement is correct. Option A, true. Hasley's method for H3 is determined by H3 square divided by H2 minus H3. Option A, true. The location of groundwater table HW is given by average of 3 readings HW1 plus HW2 plus HW3 by 3. Option A, true. Location of groundwater table is given by HW1 plus HW2 divided by 3. As it is divided by 3 means it should be another HW3. Therefore, the statement is false. His answer is B. Then the location of groundwater table HW is equal to HW1 plus HW2 minus HW3 divided by 3. Average cannot be done by using minus symbol. Therefore, it is false statement B. The location of groundwater table HW is HW1 minus HW2 plus HW3 divided by 3. Minus, as I said earlier, it cannot be done as an average. Therefore, it is false. The location of groundwater table HW1 minus HW2 minus HW3 by 3. So averaging will be done by positive sign. Therefore, the statement is false. So these are all the list of the textbooks and reference books we are used for preparation of this module. And I take this opportunity to thank Department of Collegiate and Technical Education officers for giving me an opportunity to deliver this lecture in LMS portal. And also I take this opportunity to thank the student community for listening this class. and I request all the students to go to the LMS portal and listen the video, PPT and study material and solve the MCQ question. If you have any question, you can ask in the next class. Thank you for attending the class.